How are you doing? Welcome to live stream number 155. It's Friday, man. We made it. So, it's Friday. That means cam. Today's topic is everyone can make a straight hole. We're going to talk about drilling and hole making today. Because a couple of people have emailed me and told me that every time I'm doing a cam tutorial, whenever it comes to holes, I always kind of like skip over it or go really fast. And there is actually some things in there that are really, really important and you should know about. And I think I maybe show a couple of things that even if you are, a cam ninja, you maybe did not know. Appreciate you taking the time. My name is Lars Christensen, and this is just about 20 minutes or so, trying to add a little bit of value to to your Fusion 360 cam experience today, because it's Friday. There is no live streams next week. Well, we might try to push one in Friday. I'm going to Chicago next week for some training, so but let's get into it. Okay, so last release just came out a few weeks ago, and the development team actually added a few functions to the whole drilling environment inside of cam. 2 weeks ago, two Fridays ago, I did a live stream on that what's new, but I actually also left a link down in the description area to my good friend John Saunders, who runs NYC CNC's YouTube channel. He did one the other day on them as well, and I think he maybe condensed them a little bit better than I did. So definitely go and check out John's video if you want to get into all the different new things with the hole command. I'm not going to touch on all of it today. It's definitely worth to watch. If you have not subscribed to John's YouTube channel, you would like to if you like cam. At least that's what I think. All right. So with that said, let's jump into Fusion 360 and talk a little bit about drilling. And I kind of apologize that I haven't done more about this in the past, because is it fair to say that the drilling inside of a or inside of cam, it's almost as a good sketch? I don't know. I think that personally I have just kind of like skipped a little bit over it because I thought, it's just holes. But the truth is that there is some tips and tricks with holes, and you never make a part where you don't drill some holes. So let's jump into it. I'm going to take the same plate that I've been using in the What's New videos. So there's a couple of different holes and counterbores and different things like that. So the first thing I'm gonna jump a little bit around. I'm gonna show you some tool library functions and cool stuff like that. So the first thing we normally do when we are drilling holes, I already have a setup here, is we will spot drill. And I just want to say one quick thing. If I ever make a mistake when it comes to drilling, most of the times it's because I don't click on every single box and make sure that I got all the right settings in here. That's when you normally will see me be like, ooh, I forgot something. First thing we're going to do is select a tool. Now you'll see that I already have a 90-degree countersink in here. But I wanted to talk, while we're getting in here, I want to talk a little bit about tool libraries, because why not? So you will actually see that I have my tool libraries over here, and this is how I have always done it. Now, that doesn't mean that that's the best way in the world, but you will see that I kind of have created different tool libraries, and I have them stored up on the cloud. I've talked about that before, but by default inside of Fusion, let's just go to our preferences here. By default inside of Fusion, this is not turned on. So if you want to have them up on the cloud, then you need to go into cam and turn them on. What that means is that if I log into somebody else's computer, then as soon as I log in with my ID, these libraries will be available. Now I'm just going to go ahead and select a aluminum milling, just because I know I have a spot drill in here, and I'm going to come back to the tools in a little bit. So that's the first thing. Now, when it comes to feeds and speeds, I said it before, you need to utilize whoever you buy your tools from. That is the right way to go about that, in my opinion. And then you can always tweak it later yourself. But go to wherever you buy your tools, get the feeds and speeds from them. In my experience, when I've done that, if something went wrong, they were always more than willing to replace the tool. If you just come up with your own, well, then maybe not so much. I'm going to go into geometry. I'm going to show something. John actually showed this in that video that I linked down in the bottom. But a new thing here that is really, really nice for spot drilling is that we now have a diameter range in here. So before we went in here, we just selected a face of the hole, and then we can select same diameter. But new in this last release is we can actually set a diameter range, what mean that I can actually go in here and I can say that I want to find every hole that are between 1 to 100 millimeters, and you will see that it finds all the holes, and actually it doesn't. I just discovered this this morning when I tested this out. I have already made development aware of it, but I was not going to try to hide it in here. Look, the threaded holes are not selected. I was kind of planning on maybe tapping those in the mill too. What I found, the workaround is that the reason, I'm going to come back in and make changes to the spot drill in a second. Let me just hit OK. The reason for this is that I have my threads by default modeled. I like having them kind of like modeled up there. If I go into the model environment and I go down here and find that thread, if I right click on it, hit edit feature, and instead of having model checked, I switch that to a bitmap, hit OK. So this now it's just a picture on it, and kind of a picture of a thread, but it's actually fine. Like, the only reason to have it modeled, really, I mean, anybody who's 3D printing would tell you that they would like it modeled. But kind of like in my world, to be completely honest with you, it was not a norm to ever have them modeled. It was actually never an option, because having modeled threads would normally slow down your system a lot. But in Fusion, unless you have like a lot of holes or components, you can actually model them, and I just like it. I kind of find it's cool. But for CAM, it doesn't really matter that they are not modeled, that they are kind of like a bitmap. I mean, what you will see now where I switched it over is that if I go into CAM and I right click and regenerate the toolpath, now it finds them. So I guess I just wanted to show you this just in case you was not aware of it. And I don't know. I mean, I've said it before. I am like the busboy at a restaurant. I have no power. I'm pretty low on the food chain. But I would say that in future versions, I hope they get that fixed, and we get it also on modeled ones. All right, right click. Let's go in and edit here, and I'm going to show you some interesting things about this. So first of all, we selected our tool. We have now selected with this diameter range. We can now select all these. What is really, really cool. Also be aware of you have an option in here. You can click optimize order. You can revert. You can go from order inside out. You have some different ways that you can kind of like reverse this in here. But if you want full control, then you will actually need to go in and select each hole in the order you want. Now here comes the next part of it that I think is very important. That's the heights tab. Now, I talked about the heights tab before in this live stream. I always recommend that you start from the bottom and work your way up. Only for the heights tab. Everywhere else, start from the top, work your way down. But for the height tab, start from the bottom and work your way up. And the reason for that is that is always, the bottom is always the most important, right? You're always worried about, like, how deep is my tool gonna go? So start there. And you will see that in this case it goes whole bottom, and I'm just spotting right now for my drill. And by the way, most Java drills, standard high-speed drills, have a 118 degree cutting edge on them. If you can get tools that has a flatter radius, like 120, 21. Some of them you actually don't have to spot, but normally if you're using high-speed tools, you spot first. So what I normally will do here is, well, there's two things. There's a whole top and there's a whole bottom. I would normally change the whole top to my stock top, because that's normally where that hole will be. And then you can actually switch this one here also to either a stock top or model top, and then I just write in how deep I want it to go. So for a spot drill, I normally just want it to go 2 millimeters deep, or like a little bit deep, just to steer the drill, right? The last tab is the cycle tab, and for spotting, the default drilling is fine. So I'm just going to leave that for right now. So with this, if I go in and I simulate this, oops, got to select it. Select the operation here, simulate this, and I have the stock turned on over here, and I hit play, we will now see that we get a nice little spot here for our drill. Some people would say some people have a spot drill that is big enough that they can go so deep that when they're drilling the hole, that will also kind of create the chamfer for the hole. I normally not play too much around with that. I've normally just chamfered my holes afterward, just in case. So actually, the spot drills I have always used is what is called, I think they're called the spot mill. So it's a 90-degree cutter, but you can actually chamfer with it too. So it's kind of like a tool 2-in-1. You can spot with it, and then you can chamfer with it too. Spot mill, I think, is what I have always, when I called up to order, that was what I always called them. So search for those. So this is pretty good. I'm pretty happy with this here. Again, if you watch John Saunders' videos, that is linked down in the description. He does great work. He talks about how he now will right-click here and create a template from it. So definitely, if that's new for you, you got to check out John's video. Okay, let's move on here. With some hole making here. The next tip is make a decision on in what order of holes. So if you look at this part here, you will see that there's all different kinds of sizes of holes. To make your life easier, decide today, if you haven't already, if you're either gonna go from the biggest holes to the small holes, or the small holes to the biggest holes when you're putting your tools inside of your machine. I have always started with the smallest hole and then went to the biggest hole last, for a couple of different reasons. First of all, small holes normally are more fragile, right? It's a smaller tool, has an easier way to break. So getting those kind of like over the beginning kind of makes sense. But the other thing is, many times you will use one drill to actually pre-drill a bigger hole. So if you start the other way, and the reason I want you to decide today either to go from small to big or big to small is it makes it easier when you're putting all the tools in, that you actually are following kind of like the pattern and not just all random with the drill sizes. And in this case here, I would probably use this drill here, 14 millimeter drill, to drill out some of the material for these bigger holes. So that's have always been my reasons to go from small to big. So the smallest hole on this model here is this little hole in here, right in the center here. And you can always go in Fusion, you can always go in and click measure, and you can click on the hole here and it will show you the diameter. So in this case, it's 3.4. So let's talk a little bit about tool libraries here. I'm going to go in and create a new drilling operation. I'm going to go in and say I will select a tool. And I talked about before how you can create your own libraries. So all you do is you go up here and you right click and you can create a new tool library. So now we get a tool library here, and we can call this one live stream, for example. Now it's empty. So what I normally do, and please, if you have any suggestions or comments, put them down in the comment area. People read them. If you have your techniques, love to hear about it. Then what I normally do is I will go down to the tutorial library down here, and I would look in here to see if there is a tool in the right size. There is not, but there is a 4.5 millimeter drill in here. So what I normally do is I just take that and I just drag it into my library. So now in here is that 4.5, and then so I pretty much just borrow from the tutorial libraries, drag them over to my custom folder, right click, and now I can go in and edit that tool. So general is just general description, and this can be great. I mean, I always fill these things out, so when you have to reorder them, that you can easily order them. And then you can go in here and you can do your measurement. So 3.5 was the diameter. That's probably also the shaft diameter of this one. You know, your tip length, just talked about that. Normal is 1/18 for like a standard jobber drill. Lengths or whatever. And put in here what your normal standard tools are. I'm going to show you why later on. This one here says it has 3 flutes. I have always calculated a drill as a 1 flute thing, but I'm not 100% sure if you normally calculate 1 or 2. I think 1 have always been my default. Through tool coolant, you can turn that on in here. Man, if you have like 1,000 psi through coolant, you're gonna love that. Another thing I want to show while I'm in here is if you go to the post processor tab, be aware of that not only you can change the tool number in here, so this is set to default to 33, just pulling out of the library, and that really depends on what type of machine you have, right? If you have like a smaller, like, or not a smaller, but you have like a tool room machine, or I don't know what type of machine. Some machine where you just pull, many times you pull the tools in and out constantly. You're always swapping tools out, but you could also have a machine where you have a lot of tools in it. I used to run that Matsura 11 pallet pool. It has like 219 tools in it. You didn't tear tools in and out. So that's why you have this option to plug in whatever numbers you want in here. Notice that if you are running a machine that don't have a tool changer, then you can switch here and it will actually manual stop for that. And also if you have a probe on your machine, you can turn on brake controls and we'll go over and change that. Live tool means that it will load it up. No, that means for the lathe. Oh, I thought that was pre-stage tool. Never mind, let's move on. So now we have this cutter form for this 3.5. So I'm going to select that. Again, feeds and speeds is whatever you get out of your tool vendor. We can go in here and we can then say select face, and we can zoom in here and select that face, and that's been selected. Now notice that if you click over here, select same diameter, that's a good way to check that there's not any others in the model. So there's only the center hole right here. So with that, we're going to go to the next tab. Now this is fine that this is whole top. And whole bottom is actually also fine in this case, except if we go on the bottom here and zoom in a little bit, we have a drill point, so you might want to check drill tip through bottom, and then it will actually make sure that it drills through the bottom here. You can kind of see it there in the shadow if I uncheck it, right? You can see how unchecked it will just drill to the tip, and we got to break through, and then you normally will add a little bit more just to make sure, 2 millimeters in this case, just to break through here. Now then, this is a small drill. I will definitely make sure I'm going to go over to the drill cycle over here, and this is actually pretty cool. I'm going to show you a couple of different things in here. There is a lot of different options in here, and the best thing to do is actually just hover over and see what I call the Cheesecake Factory kind of menu right here. I think the credit goes to Mike Matera, who does these. I would imagine that he was the one who wrote all these. And this is a really, really good list of giving explanation of a lot of different things you can do in here. I'm going to show some of them a little bit later. But the first one is drilling from the top. And that is what normally in G-code is called G81, but it's just drilling down to the bottom. The next one that I will normally use is either chip breaking, what is G73, or the one beneath the G83. And that really depends on kind of what tool you're using. So G81 will literally just start drilling from the top, and it will just drill down to the bottom at whatever feet rate you set, and then it will go back up to the top at the end. So just drill down up. That's kind of what we did with the spot drill. The G83, the Peck drilling, means that it's going to drill down a certain distance, and then it's going to retract out of the hole and drill down that distance again out of the hole, but retract all the way up to the top. That's normally what you would normally do if you are drilling on a drill press or something. You drill down, drill out, you kind of like get the tool in and out. G73 is chip breaking, and it means that the drill will drill down, but instead of retract all the way out the hole, it just kind of like just pulses up a little bit and breaks the chip as it's going down. So that's G73. It just drills down, and that will go a lot faster. Depending on how small your tool is, and this is where we kind of like get into what is your experience. This hole here is 3.5 millimeters, but it's a very small hole. I would probably take the time to do a G83 where it's gonna come all the way out of the hole every time. Actually, I'm gonna show you a neat trick with that one. So if we go in here and we do select the one it's called deep drilling. I think that's what I call normally like Peck drilling back in the day. But it comes with a couple of different things. First of all, the first Peck, and every time you hop over here, Mike gives you normally gives you a little like the thing that comes out. So this is how deep it's going to drill the first move down. So how long it's going to go down before it's going to start retracting out. And I don't know if this is a great rule. Somebody, please feel free to add to that in the comment area. But I have always done either just the diameter of the drill or the diameter of the drill times 1.5. Kind of depending on how brave I have been. But I think that's just how I've always done it, and I don't know. I don't think it was something I read. Now, what is neat about this is that you can actually, and this depends on your machine, you can actually reduce that pecking depth. This is what is called, I think at a Haas, it is called like deep drilling, and I think it includes now a K value in there. So what this can do is that per every peck you're doing, you decrease that depth. So the first depth down is going to be 3.5, and then if I typed in here 0.5, that means that the next only is going to be 3, and then it's going to be 2.5, and then it's going to be 2, but then in the next one you can set whatever that minimum is, because at some point you probably you can't go down to too thin, or you're just going to kind of like be fiddling around down there, right? But this is really great if you're doing like very deep drilling, that as you're going further and further down, you can kind of like reduce the depth. So I hope that kind of makes sense. So in this case here, the first one, it will go 3.5 down, then the drill will wrap it all the way out of the hole and wrap it down again. Next time it's only going to go 3 millimeters down, go all the way out of the hole, go down again, until it reaches 2 millimeters, and then it's just going to stay at that and go 2, 2, 2, but it's going to wrap it out of the hole. So that's how I would do that one. Okay, so I know this is maybe not the most interesting things if you were looking for the 4-axis video, but I think that this is kind of important. And like I said, I'm going to show you a couple of tips just in a second. So that was that hole. We're going to say that's good. Let's move to the next size hole. I think that is maybe this one here. So that is 6.5 millimeter. And the way I would do that, go in here and hit drill, select a drill, and now I would just probably go into my my library in here, live stream library, and right click on this one and just say duplicate the tool, and then go in and double click. Oh no, not double click on it. Duplicate the tool, live stream, right click and edit the tool, and go back to here and change this to a 6mm, and whatever, like we talked about before, the length, put all the right ones in, feet and speeds and all that stuff. Then if you go in here, you will see that now both of them are actually tool number one. Another tip in here is, I haven't selected it yet. So I'm going to select this one, hit OK. If I go back into the tool, I'm just going to clean this up here. So we didn't use this one anymore. Let's remove unused tools. Right click, remove unused tools. Okay. So now we actually have in here the 3.5, the spot drill. You see them all; they're all number ones in here. Unless you have one tool, that is all great. But what you can actually do is you can actually right click in here and say renumber tools. And now if I just first tool number one, hit OK, now they all are renumbered 1, 2, 3, 4 in the order that we're using them. So I hope that was not confusing. All right, let's go ahead and select that next size hole there and select same diameter. And you will see that now it's going to select all the same diameters. Perfect. Again, on the depth over here, start from the bottom, working your way up. I'm okay with the whole bottom, but we got to get the drill tip through. We got to make sure we're adding a little bit extra there. So that's good. And for this one, I would actually probably, because this is 6.5mm, I would probably go ahead and use that chip breaking G73. So this one here will move, will drill faster than the other one because it's not completely dragging out of the hole. So now you can actually set the Peck increment here, and you can see how small that is in here. And that is, I think, more of a kind of like a choice in here. So the first distance, I mean, if you could go the diameter, and then down here you set how much it's going to lift up the tool. What maybe is like 0.5mm or something like that. It just pulses up as it's drilling down. Again, in here you can set a specific depth where it's pecking until it will start going all the way up to the top. If the hole is very, very deep, then you will just have it, you set this depth here. If it's over 15mm, I actually wanted to start reacting like our other operation we just did before. Okay, cool. Now I see that I'm coming up on the half an hour, so either I talk a lot or we're just gonna run a little bit over here. Next thing I want to show you is a couple of other things, and I think it's because I'm mixing in this this tool library here. Let's do the pre-drill for these counterbores here and the big holes. So I'm going to select another drilling operation. I'm going to go in and select the tool. And again, I would probably do just like I did before. I'll go in here, I right click and I duplicate one of these tools. I right click and I edit it. And now I know these are 14mm holes for those counterbores. For the screws, 14 and 14. And you can see here that the tool is probably longer too, but you can see here that this looks a little weird. Actually, I never used drill chucks in a CNC mill. I would normally go over to the holder section and use something else. Something like I used to use a lot of ER. Let's see here. What do we got? ER 32, maybe something like this. That's with a collet in it. That's what I would actually normally use for something like this. So you can switch and do that if this is tools you're going to use fairly common. Make sure you got all the right the right ones in here. I'm going to hit OK to that. And this could be where I just decide to go in and use that range again. And I could say, well, I want every hole that is 14 millimeters, and it picks those 4 that are new. And then I'm going to go just high to make sure that I also get these holes here. So this is why I'm going from small to big, is because I want to reuse these as a drill through, just like that. Same thing as before. Make sure you hit all the different tabs. Same thing as before. Go in and do your drill through the tip here and go past it. So make sure you go past the whole bottom in here. Make sure that when you go over to your section over here, I mean, for something like this, what is this, a half an inch diameter, a little bit bigger than a half an inch, I would again probably use the chip breaking for that. 14 millimeter depth, whatever kind of like fits in here, going back to what we just talked about. Okay, so that was a little bit about the drilling. Now let's talk about these holes in here, because now we're talking about making holes, and the title of this is Everyone Can Make a Straight Hole. I wanted to touch a little bit about some tips and tricks with that. First of all, holes like these counterbores for screws, I would actually normally use a regular end mill for that. I would not use some counterbore set or something. I would just use a half-inch end mill or something like that, just to mill that out, or 10 millimeter or whatever we're going to use here. A couple of different tips on that. You could be tempted to go in and just use something like a 2D contour. Let's go down to the tutorial library and select a cutter, 10 millimeter, because I know that will fit in these holes. And then you could just go around and select, the edge in here. That will give you, that will work. But also be aware, if you go over here to the drop down, there is also one option over here called circular, and that will actually adjust depending on kind of like more on your part. So if I go in and select the same cutter like this, instead of selecting the geometry, we are now actually selecting the holes. Now you do have to, in this case, select the different diameters that you want. Here, we need these. Well, actually now I was just going to do the counterbores. Of course, I haven't done these. I would probably do these holes first before I did the counterbores. But I'm going to come to that just in a second. So it kind of does the same thing as a contour operation. Though that when you go into the passage tab, you will see that there's a little bit of a different, it looks a little bit different in here. It's a little bit easier, I think, than the contour. There's less things in here. You can add multiple passes in here if you want to. So maybe now you can see that we have, the reason I didn't see any was because it would have interfered with these holes over here. Now we have 2 operations, number of step overs in there. You can add multiple depths in there. You can see that is checked. I think this is straightforward. So if you're doing counterbores, I actually think that the circular operation, in here is actually a little bit easier, simpler than using a contour, but it's kind of doing, I think, the same type of thing. But the next thing I wanted to talk about was these bigger holes in here, to get those to size. So a couple of things. There is a boring operation in here. So the difference between a circular operation and a boring operation is that if I select the circular operation and I select this hole and we zoom in a little bit, what you will see is that we get a lead in, lead out on every single 1 millimeter depth down, right? So it's going to go one circle and go down. If you do a bore instead, then it's more like a spiral that it will be machining. You know, we'll start up here and it kind of like doing almost like a screw contour all the way to the bottom. Again, you can go in here and play with the pits depending on how you want that. But that's normally, if you're doing holes like this, this could be one of your ways to use this. Now I'm saying that it could be. It's because you might just have to experiment a little bit with this, depending on what type of machine you're using, what type of material you're cutting, and type of cutters. And then I want to show you something that you may be not aware of. But if I go in to the drilling operation, and I leave it at the 10 millimeter flat end mill here, if I select this hole as a drilling operation, but I go back into this last tab, the cycle tab, you will actually see that down towards the bottom, there is a lot of different options in here that can be used with a boring head, or for that matter, actually with an end mill too, for example. So this here, a boring dwell, feed in, feed out, actually works just like the boring command I just showed you, except in this case, it can be called out in the post with a G code, what may help your machine. For example, if I select circular pocket milling here, and you will see again we get some settings. So, well, how big is the hole? I know that's 30. Let me hit OK to that. Now it doesn't look like anything. It looks like a drilling command, but if I click the simulate button in here, then you will actually see it does very much approach this as a circling mill, though that it was a drilling tool path that we use. So if you didn't know this as a power user, this will definitely be something that you should have a chance to, you should take the time to look at. So on the last tab in here, there is all kinds of options of call outs, and the cool thing is that these can be controlled in your post, which means that you can do all kinds of automated things in here. Let's say that you want, your machine has a special call out cycle. You can control these right from within with one of these call out. Now the last thing I wanted to talk about in regards to straight holes, that is that especially if you're machining things that are hard, one of the issues can be tool deflection on a long hole like this. Like this is a long hole down to the bottom, and you might want to use a bore, but I've actually also many times done this with a end mill. I've machined that out. But one of the problems you can run into when you are machining something like this, that is that your tool will deflect. So think about it like you have this long drill that's sticking out, or long end mill is shooting out this far, and as soon as it hits, if you're starting from the top working down, as soon as it hits there, it kind of it deflects off, and then as you're going further down, it kind of like just goes in and gets deflected off. One of the tricks that I have used fairly successful was actually using the fret mill option, because that will let you go from the bottom and up through. So actually you send your end mill all the way down to the bottom, right? And then as you're starting machining up, you're not getting that beginning where it just deflects off at the tip. Now actually you have kind of like the whole support of the end mill kind of in there as you're going up. So that's one thing to do. Another thing that you can do is actually relieve your cutter a little bit. So let's say you have a cutter where you have a 1-inch flute length on it. If you reduce that down, you put up like on a diamond grinder or something, and only take off like a very small amount of the cutting edge. But if you reduce that down to a smaller amount, you can actually get a better result than that. So actually going in here and picking a fret milling operation instead, selecting the tool, selecting the hole, and of course again you can play with the pitch you want in here, and then now the tool will start from the bottom and work its way up. Now, but it's going to show you another thing that I want to make sure you're aware of when we do holes in here. See how that tool is now in red? That is important. This is your look into the future, right? We have all these collisions in here. Anytime you see your tool goes red or you get a red down on the screen, you need to make sure that you double check, because the software is actually helping you out, letting you know that there is collisions in here. I'm going to avoid them for now, but this here will let you machine from the bottom and machine up, and this should help you making a lot straighter hole than starting from the top. At least I have done some experimenting around with this, and it did help me. So that was with kind of like with the fret mill in here, and then just take, you know, like, I don't know, less than 15 thousandths off the top section. So it's only this section here that cuts, but you don't want to take too much off, because then you are losing the rigidity of the cutter. But that can kind of help you. That can kind of help you too. That was about it. That was what I had. That was what I had planned on talking about this Friday. I hope this was useful. There was definitely one of those things that I have to admit I had not covered hole making, and I should have, because there is a couple of things in there that you know, you should be aware of. We made it. It's Friday. It is May 4th, 2018. I hope you have a really, really awesome weekend planned ahead of you. Like I said, next week there will not be any live streams. Maybe Friday. I'm not quite sure. I don't know how tired I am after my travels to Chicago. But I hope you have an awesome weekend. I hope you have an awesome next week. If you like this, thumbs up. If you don't, be honest. Put the thumbs down. And again, if you haven't already subscribed to the live stream or to the channel, I would truly appreciate it. Thank you so much, everybody. I hope you have an awesome weekend and week.